Hi, my name is Alanelli, and so for the introduction, caffeine is a naturally occurring stimulant that is commonly found in beverages such as coffee, tea, and energy drinks. It is widely consumed because it helps increase alertness and reduce fatigue. Due to its widespread use, identifying and analyzing caffeine in beverages is important in both food chemistry and analytical chemistry. One of the most effective and simple technique used to separate and identify chemical compound is thin layer chromatography, which is TLC. TLC works based on the different affinities of compound towards the stationary phase and the mobile phase, allowing substances to be separated and identified based on their movement on a TLC plate. In this experiment, thin layer chromatography is used to separate and identify caffeine in various beverages by comparing their RF values, which is a caffeine standard. This method demonstrates how chromatographic technique can be applied in real-life situations, particularly in analyzing components found in everyday consumable products.
Hi, my name is Najwa and I will talk about theory of thin layer chromatography. Thin layer chromatography (TLC) is a solid liquid chromatography technique in which compounds are separated based on their affinity toward the stationary phase silica gel and the mobile phase solvent. When the solvent rises through the TLC plate by capillary action, different components travel at different speeds depending on their polarity and interactions with the silica surface. The identity of compound is commonly determined by their retention factor RF value, calculated using the ratio of the distance traveled by the solvent front. Compounds with matching RF values under the same conditions are likely to be the same substance.
Hi everyone, my name is Siti Nurjamila binti Idris. Today I will explain about the objective of this experiment. The main objective of this experiment is to separate caffeine from selected beverage sample using thin layer chromatography, commonly known as TLC. Thin layer chromatography is an analytical technique that allows the separation of compounds based on their different affinities between the stationary phase and the mobile phase. In this experiment, TLC is used to observe the chromatographic behavior of caffeine on a TLC plate as it travels with the solvent. Furthermore, the presence of caffeine in the beverage sample is identified by comparing the RF value obtained from the sample with the RF value of a standard caffeine solution. By comparing this value, we can confirm whether caffeine is present in the selected beverage and evaluate how effectively TLC can be used for caffeine analysis.
Hi, my name is Nur Alana Suha. For this topic, we use the TLC technique. It used to separate and identify caffeine present in beverages. The separation occurs based on differences in polarity between compounds. Silica gel acts as the polar stationary phase, while a solvent system serves as the mobile phase. Less polar compounds travel further on the TLC plate compared to more polar compounds. For the material and the apparatus, the material we use caffeine standard, beverage samples like coffee, tea, and soft drinks, mobile phase solvents, and distilled water for solution preparation. For the apparatus, we use TLC plates as a separation medium, a beaker as a developing chamber, capillary tubes for spotting samples, a UV lamp to visualize caffeine spots, and a hot plate to concentrate the sample. Next is the sample preparation. Beverage samples like coffee, tea, and energy drinks were first filtered to remove the solid particles that could interfere with the chromatographic separation. The filtered samples were then gently heated to reduce their volume and increase the concentration of caffeine. After cooling, The samples were ready for TLC analysis. A standard caffeine solution was prepared separately and used as a reference for comparison during the experiment. For the experimental procedure, the TLC produced follows standard chromatographic practice as described. A baseline was drawn on a silica gel TLC plate, and small amounts of the prepared beverage samples and standard caffeine solution were spotted using capillary tubes. The TLC plate was then placed in developing chamber containing an appropriate mobile phase solvent system, commonly a mixture of ethyl acetate, methanol, and water. The solvent moved up the plate by capillary action, allowing the separation of caffeine from other components in the sample. After the development, the TLC plate was removed and dried before being visualized under UV light. Caffeine appeared as a dark spot due to its UV absorbing properties. The distance traveled by the caffeine spots and the solvent front were measured, and the RF values were calculated to confirm the identity of caffeine in the beverage sample. Next is data analysis. The distance traveled by each caffeine spot was measured from the baseline, and the distance traveled by the solvent front was also measured. The RF value was calculated using this formula. RF equal to distance traveled by the compound divided with the distance traveled by the solvent front. The RF value of the samples were compared to the caffeine standard. Similar RF values indicated the presence of caffeine in the sample.
The table shows the TLC results for crude, purified, and standard caffeine using ethyl acetate as the mobile phase. The solvent front traveled 8 cm for all samples. The crude caffeine spot traveled 0.97 cm, giving an RF value of 0.121, while the purified caffeine traveled farther at 1.15 cm, resulting in a higher RF value of 0.144. The standard caffeine traveled 0.99 cm with an RF value of 0.124. The RF value of the purified caffeine is close to that of the standard caffeine, indicating that the purification process was successful and that the purified sample contains caffeine. The slightly lower RF value observed for the crude caffeine suggests the presence of impurities that affected its movement on the TLC plate.
So, for the discussion, this experiment shows that the thin layer chromatography is a simple and effective way to identify caffeine in beverages. We first prepared the sample by filtering and heating them to concentrate the caffeine, which helped us to get the clearer results. We use silica gels as the stationary phase and a suitable solvent as the mobile phase to separate the compounds on the TLC plate. When we observe the plate under the UV light, caffeine showed up as visible spots. The RF values from the beverage samples were very close to the standard of caffeine, which confirms that caffeine was present. Overall, this method is reliable, easy to carry out, and works well for identifying caffeine in different drinks.
My name is Nur Nazira, and the last part is conclusion. Thin layer chromatography, TLC, successfully separated and identified caffeine in the tested beverage. By comparing the RF values of beverage sample with a standard caffeine solution, the presence of caffeine was clearly confirmed. TLC is shown to be a fast, inexpensive, and reliable chromatographic technique suitable for identifying compounds such as caffeine without requiring sophisticated instruments. That's all from us. Thank you.